Everybody, I wanted to make a brief video on the homework to help clarify one of the questions that we had so that it'll be a little easier for you to take a peek at this. Number 9 out of the homework asks for you to look at figure 1 in the paper that we have assigned and gives you several different patients to go through, patients 15 through 30. So what I'm going to do is try to illustrate how this works by going through another patient, patient 32, out of the sequence, so you can just see what I was looking to do here. What we're looking for is basically, here's the patients that we had and their visual deficits. This is a combination of both the left and right eye. So what we're looking at then is that this damage up in this right upper quadrant of the visual field, and we're assuming that it's actually going to affect both eyes. And that's this slide that we have of heminopia that came from our PowerPoint slides. It's under the vision, and then there's a PowerPoint slide just dedicated to this solely. And so what we see if we open this up is that the two eyes are separated from each other. So when you're looking at this and you're trying to compare, like, okay, I've got this here, how does that compare to what we have here? Just assume that it's the right upper quadrant and that both eyes are applying to it. And that can help you figure out where a lesion could possibly be. And so if we do that and we kind of trace it back, so let's kind of move this over a little bit and move this over here, and we can kind of just work this back. And what we find is basically that we have this quadrant here. It gets flipped and it also gets transformed left and right orientation. So now the information is being carried back through this line here and then back through the Myers loop to the visual cortex. And then on this side here, the right upper quadrant here is flipped and it's upside down, so it's right down here. This crosses the optic chiasm and then checks back here. So they course together back here in the Myers loop after you pass the LGN. So one idea is that basically if you target anything in this region right here, then you're going to have that really specific type of deficit there. And so that's the kind of thing that I'm looking for in terms of your thinking. Points of confusion that could come up are, you don't have to necessarily completely reconcile it with what they have in the table here. So for example, patients 15, 16, 30, and 32 all have these different types of deficits, and they show where the location of the lesion is, but they only specify it to what the particular lobe is that's affected, and so that makes it a little hard to actually reconcile it with like a specific lesion that I was looking for. And so what we're really just trying to do is to get an idea of what's one particular area that could be responsible for these visual deficits that we have here. Larger scope of lesions that happen here are, could explain some of the other issues that are part of that motion perception issue. But I just wanted to try to take these types of visual field deficits here and have you apply it. So I'm looking for you guys to create some kind of an image like this, illustrating where exactly you think the lesions are. And by exactly, I mean what sort of region here, over here, so on and so forth, to help be able to get into what's going on. In patient 30, there's the foveal regions preserved, so it's a little trickier to be able to do that, but just assume that it's the right upper and right lower quadrants that are affected. Okay, do your best with that. We're just looking for you to kind of capture what they have, what the possibilities are using this diagram. Hope that helps. Thanks.